In this video, I'll be showing you how to export your 3D design made in Autodesk Fusion to Bambu Lab so that you can have the model prepped for 3D printing and use the slicer software to prepare your mesh. Alright, so after making your complete assembly, you would want to choose the actual parts that you're trying to 3D print. Now, while I was designing this assembly, I used the hybrid design mode, which I can see here, hybrid design, and the parts are internal components. All right, so I do not have separate files for each part that makes up this assembly. I have these components built into the main assembly file. And in order to export a single part, when you have internal components, you would have to export that individual component as an F3D file. So you cannot just export as an STL directly for internal components. You can only do direct STL exports for external components. Or you can do an STL export for the assembly as a whole. So if you come to the top left corner, the file tab up here, click on that, you find export, and you'll be able to export STL. But if I do this, I'll only export the entire assembly, and I don't want to do that. I want to pick a particular part that I'm interested in, that I actually want to 3D print and send to Bambu Slicer. So to do that, if I want to 3D print the base here, which is the fork stand, is it fork stand? We have the axle cap, roller, axle, fork. Yeah, the fork stand. If I want to 3D print the fork stand, I first have to export the fork stand as an F3D and then later as an STL, just because I made it as an internal component. Alright, so for this, I'll right click on fork stand and click export. I can see fork stand fusion files F3D. I want to export it to my computer. And this project was originally a class exercise. Alright, so it's not for this, but I'm exporting to my computer and it's going to be in this folder, GET203 folder that I've created previously. If you want to select a new folder, you can just click on this three dots icon here to browse to a new location where you want the export to be saved. But I'm okay with this location, so I'll just click export. So what it's going to do is to bring up a menu. Okay, I think since the location is already selected, it should be exported now. Let me just try to open the location. So this is my file explorer. I'm going to GET203 where I saved that. Oh, I can see it there already. It has been exported. Fork stand F3D. So you will have to open this newly exported F3D that contains only the fork stand. And then from here, you'll be able to do your STL export. So I'll double click on this and open forkstand.f3d in Autodesk Fusion. Alright, so it's open right now. And now that I have a single part in Fusion, I can export as an STL file. So you come again to the top here, there's a file button that brings up a pop-up menu. You click export, and if you check the list now, you'll find STL. So STL is what I'm going to send to Bambu Slicer. You can also send step files, I think, but STL is what we use for the sake of the exam. So, and I'm making this video for those who requested me to make a kind of guide, how-to guide for Bambu Slicer. So STL, that's what we're using. It's going to be the same Meki GT203 folder that I have here. So export again, should be exported now. Okay. So I have the forkstand.stl. By default, Bambu Slicer is my STL file viewer. So I can see Bambu Slicer icon here. What that means is that if I just double click on it, it will open Bambu Slicer. But if Bambu Slicer is not your default STL viewing application, you just right click on it and say open with. So I'm opening this STL file with Bambu Slicer since I have different applications that come up with STL. So Bambu Slicer application is loading, Bambu Studio, loading configuration. Okay. Okay, so I can see the Bambu Slicer application loaded and my model is sitting right on the plate. So if the orientation of your parts is not placed properly, it's advised to make sure that you have the largest flat section sitting on the base. So this one looks good. I have the widest flat area sitting down because the 3D printer prints from bottom to the top. It prints from the bottom up. Alright, so you need the widest area down so that wide area below will support the rest of the model. Okay, so you can position it, move it around, you can rotate. You just hover above all these icons, you see what you can do. So this is for move, this is to rotate, this is to scale, this is to lay on face. So if I want to, let's say I want this face to be down, see it turns around. But this is not how I'm going to 3D print. I want this face to be down, so I click there. So you can use lay on face to choose a particular face that you want to be flat, that you want to use as a floor. Alright. So that's that. You can just go through all of these. I'm not really using all. So once you have your model here, it's pretty simple. You need to set up just to make sure that we have things set up right. So the 3D printer that we're working with is Bambu Lab P1S. The plate we're using is a textured PEI Plate. Diameter 0.4. I don't think we really have to focus a lot on this. Then you can select the filaments because there are different filaments for 3D printing. You have PLA Basic. Alright, if you check the Bambu menu, yeah, you have different PLA filaments. There's PLA metal, PLA matte, PLA whatever. Just leave it as the default, PLA Basic. I think that's what you have. Alright, so if everything here is right, if you've gone through and the settings match the design that you're working with, you can just go ahead and slice plates. That's the main thing here. So slice the plate. If the model is not positioned well and it brings up an error message like no support or whatever, you can just come to this support section and add external, you enable support. But I don't think we'll have any support problem here because it's sitting flat. Alright, so I can just go ahead and slice. And on slicing the plate, it runs the slicing operation. Oh, so you can see here, it seems object Fox standards a floating cantilever. Please rearrange the object to enable support generation. So I enable support generation here. Okay, and I'll try to slice again. So it turns out we need the support then. Okay, so if it gives you that error message that there's an overarching bend, that is there's a part of the object that is extending above, is stretching out and there's nothing below it. It's like there's a kind of gap below and there's a solid on top. It won't be able to 3D print that kind of structure, and it will need support, so you have to enable support to print that. So the slicing has been done. It gives you some basic information of the amounts of material that will be used to print, how long it takes to print, the time it takes to prepare before it starts printing, and all that. So after you've done the slicing, for the sake of this, I'm not using all that information. You just come to export plate sliced file. So here we're going to have a G.3mf file that contains the instructions that the printer will use to move the printhead in order to lay the deposit, the molten filament deposit that forms the object as it moves around. So it's just a set of coordinates based instructions that tells the printer how to print the object. So I'm going to export the plate slice file, and we also need to save that file in our folder, the folder where all our drawings and animation and every examination file will be saved. Alright, so export plate slice file. Alright, it's not even named, so I can name it fork stand .g.3mf. I want to save it in the same folder that I've been using, this GET203 folder. So that's where I'll save it. So, and that's basically what we're required to do for Bambu Slicer or Bambu Studio. So I hope this video is helpful, and you'll be able to reproduce these steps to get your sliced file for whatever design that we come across in examination. Thank you for viewing.